You know what farmers say about old hay balers? They run forever, right up until they don't. And when these iron giants finally give up the ghost, they take half your summer harvest with them. Today we're counting down 10 legendary hay balers that earned their reputation for reliability only to break farmers' hearts when they finally met their match. Number 10. The New Holland Super 78. The New Holland Super 78 square baler rolled off the production line in the early 1960s and quickly became the workhorse that small to medium farms swore by. This machine had a simple promise: feed it hay, and it'll spit out perfect 14 by 18 bales all day long. And for the most part, it delivered on that promise for decades. Farmers loved the Super 78 because it was straightforward. No fancy electronics, no computerized systems, just good old mechanical engineering. The plunger system was robust, the knotter mechanism was reliable, and the PTO shaft could handle just about any tractor you hooked it up to. Many of these machines baled millions of pounds of hay without breaking a sweat. But here's where the Super 78 earned its place on this list. That beautiful simplicity came with a hidden cost. The main drive gear, a massive piece of cast iron that transferred power from the flywheel to the plunger, had one fatal flaw. After years of service, tiny stress fractures would develop in the casting. You couldn't see them, you couldn't predict when they'd fail, but when that gear finally let go, it didn't just break, it exploded. Farmers would be halfway through a field when they'd hear a sound like a gunshot, and suddenly their Super 78 was reduced to a 2,000-pound paperweight in the middle of their best hayfield. The real kicker? That gear was no longer being manufactured after 1985. When it broke, you had three options: scour every salvage yard in 3 counties, pay someone to custom cast a replacement for more money than the baler was worth, or park it behind the barn as a monument to better days. Number 9. The John Deere 24T. John Deere's 24T baler, produced throughout the 1950s and into the early 60s, represented the company's answer to the post-war farming boom. This was the baler that helped mechanize thousands of family farms across America. With its distinctive green paint and yellow wheels, the 24T was instantly recognizable in any hayfield. The 24T used what Deere called the floating chamber system, which automatically adjusted to varying crop densities. This was revolutionary at the time. The machine could handle everything from light alfalfa to heavy timothy without constant manual adjustment. Farmers could run these balers for entire seasons with minimal maintenance, just regular greasing and the occasional belt replacement. The genius of the 24T was also its Achilles heel. That floating chamber system relied on a series of precisely machined sliding mechanisms and spring-loaded components. In dry, dusty conditions, which is exactly when you're baling hay, fine particles would work their way into these sliding surfaces. Over years of operation, this created wear that was nearly impossible to measure or predict. When a 24T finally gave up, it usually happened in the same way. The sliding mechanisms would seize mid-stroke while the plunger was fully extended. With the flywheel still spinning and the PTO still engaged, something had to give. Usually it was the main connecting rod, which would bend like a pretzel or snap completely. Once that happened, the repair was so extensive that most farmers just walked away. The chamber would need to be disassembled, the sliding ways would need to be remachined or replaced, and the connecting rod assembly would need complete reconstruction. For a baler that might be worth $800 on a good day, a $2,500 repair bill just didn't make sense. Number 8. The International Harvester 46. International Harvester's Model 46 baler came out in the late 1950s and built itself a reputation as the baler that could handle wet hay better than anything else on the market. While other balers would jam and clog when the hay had a bit too much moisture, the 46 just kept on chunking out bales. This made it incredibly popular in regions where weather windows were tight and farmers couldn't always wait for perfect drying conditions. The secret to the 46's wet hay performance was its aggressive feeding system. The pickup used longer, stiffer tines than competitors, and the packer mechanism used a different cycle timing that gave wet material more time to compress before the plunger hit it. For farmers dealing with unpredictable weather, this baler was a godsend. Many 46s baled hay for 30, 40, even 50 years without major issues. But that aggressive feeding system was both blessing and curse. Those stiff tines and heavy-duty pickup components created tremendous stress on the main frame. The 46's frame was built from formed steel channel, which was strong but not immune to metal fatigue. After decades of pounding, hairline cracks would develop at the stress points, particularly where the pickup mount attached to the main frame. These cracks would propagate slowly at first, then suddenly accelerate. A farmer might notice the balers seeming slightly out of alignment. Maybe the bales weren't quite as square as they used to be. Then, on a hot July afternoon in the middle of the second cutting, the frame would simply split apart. The front section with the pickup would drop to the ground, and the rear section with the bale chamber would tip backward. The machine would literally tear itself in half. Welding repairs were possible but tricky. The frame steel was old, often contaminated with decades of oil and dirt, and proper welding required extensive prep work that few farm shops were equipped to handle properly. Number 7. The Massey Ferguson 10. Massey Ferguson's Model 10 baler, introduced in 1961, was the company's entry into the small square baler market, and it came out swinging. This compact baler could be pulled with smaller tractors, making it perfect for operations that didn't need industrial capacity. The MF10 was also one of the first balers to feature adjustable bale density, giving farmers control over whether they wanted lighter bales for easy handling or denser bales for storage efficiency. The MF10 developed a cult following among hobby farmers and small operations. It was nimble, relatively lightweight, and surprisingly durable. Many of these balers ran trouble-free for decades, passing from one generation to the next. The knotter system, in particular, was beautifully engineered and rarely gave problems when properly maintained. Where the MF10 earned its spot on this list was in its needle mechanism. The needle that threaded twine around each bale was operated by a system of cams and followers that required extremely precise timing. This timing was controlled by a brass bushing that, under normal circumstances, would last the lifetime of the machine. But if a farmer ever ran the baler without proper lubrication even once, that brass bushing would develop scoring that threw off the timing by microscopic amounts. For a while, everything would seem fine. Then, gradually, the knotter would start missing ties. First 1 per 100 bales, then 1 per 50, then more frequently. By the time the problem became obvious, the damage was done. The cam followers would be worn, the needle drive shaft would be scored, and the brass bushing would be so damaged it could barely be removed. The repair required complete disassembly of the needle drive system and replacement of parts that were by the 1990s nearly impossible to find. Many perfectly good MF10 balers ended up retired because of a $50 brass bushing that had failed years earlier. Number 6. The Alice Calmer's Roto Baler. Now we're getting into the truly unique machines. The Alice Chalmers Roto Baler, produced from the late 1940s through the 1960s, was completely different from every other baler on this list. Instead of making square bales, the Roto Baler made round bales, and it did this decades before round balers became mainstream. The machine picked up hay and rolled it into cylindrical bales inside a rotating chamber. It was revolutionary, bizarre, and surprisingly effective. Farmers who ran roto-balers loved them for their simplicity. There were no knotters to adjust, no twine to thread, no needles to time. The hay was simply rolled up, tied with twine by hand after the bale was formed, and ejected. The round bales shed water better than square bales and could be stored outside with less spoilage. For operations in rainy climates, this was huge. The roto-baler's downfall was mechanical elegance taken too far. The entire rolling chamber was essentially one giant bearing surface, with the bale itself acting as the bearing between rotating and stationary components. This worked brilliantly until it didn't. If any foreign object got into the chamber, a rock, a piece of fence wire, anything hard, it would score the smooth rolling surfaces. Once scored, these surfaces would wear rapidly and unevenly. The symptom was bales that wouldn't form properly. They'd be lumpy, misshapen, or they'd fall apart during ejection. By the time this became obvious, the damage was extensive. The chamber plates would need resurfacing, the roller chains would need replacement, and various guide surfaces would need rebuilding. This work required specialized machining that most farm shops couldn't handle. The tragic part was that a roto-baler might work flawlessly for 20 years, then encounter one rock in the windrow and be effectively destroyed in 5 minutes. Many of these innovative machines met their end, not from age or wear, but from one moment of bad luck. Number 5. The Ford 530. Ford's Model 530 Baler came along in the 1970s when Ford was making a serious push into the full-line farm equipment market. The 530 was their statement piece, a medium-capacity square baler that incorporated modern engineering while keeping maintenance simple. It featured improved feeding, better knotters, and a design that made routine service easy. For many farmers, the 530 was the perfect balance of capability and practicality. These balers gained a reputation for consistency. They made uniform bales, handled varying crop conditions well, and didn't require constant tinkering. The flywheel was properly balanced, the plunger stroke was smooth, and the overall design minimized vibration and stress. Many farmers ran their 530s for entire seasons without issues beyond routine maintenance. The Ford 530's weakness was less obvious than other machines on this list. The entire baler was held together by a combination of bolts, pins, and what engineers call interference fit components, parts that are pressed together so tightly they become essentially one piece. Over years of vibration and stress, these interference fits would gradually loosen, not enough to be visible but enough to introduce play into the system. This play would cause components to shift slightly during operation, changing the alignment of critical parts. The knotter timing would drift, the needle alignment would shift, the plunger would start hitting the chamber walls. All of these problems would develop so gradually that farmers often didn't notice until things were seriously out of whack. By then, attempting to restore proper alignment was like trying to straighten a house that had settled on its foundation. Everything was interconnected, and fixing one problem often revealed two more. Many Ford 530s ended their service lives not with catastrophic failure, but with a slow decline into unreliability that made them more frustrating than useful. Number 4. The Vermeer 605C. Moving into the modern era, the Vermeer 605C round baler from the 1980s represented the new generation of hay equipment. This was when round balers were becoming mainstream, and Vermeer was at the forefront of the technology. The 605C could make consistent 4-foot bales, featured a simple chain and slat design, and was praised for its ease of operation. Many custom balers and large operations relied on these machines for their efficiency and capacity. The 605C was built tough, with heavy-duty chains, robust drive systems, and components designed for commercial use. These balers could run from sunup to sundown, day after day, producing hundreds of bales per season. The chain and slat system was particularly praised because it was relatively simple to maintain and didn't require the complex belts of competing designs, but the 605C had a ticking time bomb hidden in its design. The main drive sprocket, which transferred power from the PTO to the entire baling system, was manufactured using a process that occasionally resulted in internal flaws in the metal. Not every sprocket had these flaws, probably less than 5%, but the ones that did were disasters waiting to happen. The sprocket would run perfectly for years, sometimes a decade or more, then suddenly shatter under load, not crack, not wear out, but literally explode into pieces. When this happened, the consequences were severe. Flying metal would damage chains, bend shafts, and sometimes even puncture the bale chamber. Farmers would go from baling perfectly good hay to having a $15,000 pile of damaged equipment in seconds. The truly frustrating part was that there was no way to predict which machines had the flawed sprockets. You could inspect it, ultrasound it, X-ray it, and never see the internal flaw until it failed. Many Vermeer 605C owners sold their machines or traded them in not because they had problems, but because they couldn't stand the uncertainty of wondering if today would be the day the sprocket let go. Number 3. The Heston 55 Ford Hand. The Heston 5540 round baler from the 1990s was a technological marvel. It featured a variable chamber design that could make bales from 3 to 5 feet in diameter, electronic monitoring systems, and innovations that made it one of the most advanced balers of its era. Farmers loved the flexibility and the consistent bale quality. The 5540 could handle everything from light straw to heavy alfalfa with minimal adjustment. What made the 5540 truly special was its bale density system. Electronic sensors monitored the bale as it formed and automatically adjusted the chamber pressure to maintain consistent density. This produced bales that were uniform from core to edge, which meant better storage, less spoilage, and easier handling. It was like going from a flip phone to a smartphone. Suddenly, all the older technology seemed primitive. The 5540's downfall was being too far ahead of its time. Those electronic systems that made it so capable also made it vulnerable. The sensors, control modules, and electronic actuators were exposed to one of the harshest environments imaginable: dust, moisture, vibration, and extreme temperatures. The electronics were sealed, but seals don't last forever. After 5 to 10 years of operation, the electronic systems would start failing. A sensor would give false readings, a control module would glitch, an electronic actuator would stick. Each failure would cause the baler to behave erratically, making loose bales, stopping mid-cycle, or refusing to operate at all. The diagnostic process was complex, requiring specialized equipment that most farm shops didn't have. Replacement electronic components were expensive, often several $100s for a single module. Worse, fixing one electronic problem often revealed others that were failing. Many Heston 5540 owners found themselves caught in an expensive cycle of replacing electronic components, each failure costing more in downtime and parts. Eventually, the calculus shifted from "can we fix it" to "should we fix it," and many of these advanced balers were retired while their mechanical systems were still perfectly good. It was heartbreaking to see such capable machines defeated not by wear and tear, but by electronic components that couldn't survive the farm environment. Number 2. The New Holland BC506 die. The New Holland BC560 small square baler, introduced in the early 2000s, represented the pinnacle of conventional baling technology. This machine had it all: high capacity, excellent bale quality, modern conveniences, and enough automation to reduce operator fatigue. The BC5660 could produce up to 100 bales per hour, featured an automatic twine tier system, and included monitoring systems that tracked everything from bale count to knotter performance. Farmers who invested in the BC5060, and at $30,000 to $40,000 new, it was definitely an investment, expected a machine that would serve them for decades. And for the most part, the BC5060 delivered. The basic mechanical systems were sound, the capacity was impressive, and the bale quality was consistently excellent. Many operators reported trouble-free seasons, cranking out thousands of perfect bales. The BC506T's Achilles heel was in its plunger system. To achieve high capacity, New Holland designed a plunger mechanism that operated at higher speeds and pressures than traditional designs. This required a main crankshaft that was larger, more complex, and under greater stress than conventional balers. The crankshaft was a forged steel component, properly heat-treated and designed to last. But the bearings that supported this crankshaft were working at the very edge of their capacity. In high-volume operations, particularly in commercial baling, where the machine might run 10 to 12 hours a day, these bearings would wear faster than anticipated. The wear wasn't obvious from the outside. There was no excessive noise, no vibration, no clear warning signs. But internally, the bearing clearances were increasing, allowing microscopic amounts of movement in the crankshaft. This movement created stress concentrations at exactly the wrong points on the shaft. Eventually, the crankshaft would develop a fatigue crack. Once started, this crack would propagate rapidly. The typical failure scenario involved the baler running normally, then suddenly making a horrible grinding sound followed by complete seizure. The crankshaft had cracked through, the plunger mechanism had locked up, and the entire baler was reduced to immobility in seconds. The repair required complete disassembly of the plunger drive system, a new crankshaft that cost several $1,000s, new bearings, and careful inspection of every related component. Labor alone could run into thousands more. For many owners, especially those whose machines were now 10 to 15 years old, this repair cost approached or exceeded the baler's market value. It was devastating to have such a capable machine destroyed by bearing wear that couldn't be detected until it was too late. Number 1. The John Deere 348. Taking the top spot is the John Deere 348 small square baler, a machine that probably baled more hay across North America than any other model of its generation. Introduced in the late 1990s and produced into the 2000s, the 348 was everywhere. It was the baler that medium to large operations chose when they needed reliability and capacity. With features like maxi-cut crop cutting, wide pickup, and consistent bale density, the 348 set the standard for conventional square balers. The 348 built an almost legendary reputation. Farmers talked about running these machines for entire seasons without issues. The knotters were reliable, the feeding system handled varying crops well, and the overall build quality was what people expected from John Deere. Many 348s accumulated tens of thousands of bales without major repairs. For custom operators and large farms, the 348 was the gold standard. So why does this reliable workhorse take the #1 spot on our list? Because when the 348 failed, it failed in the most expensive and frustrating way possible, and it happened to a significant percentage of machines after they reached 10 to 15 years of age. The issue centered on the main frame structure. The 348's frame was a complex welded assembly that supported the entire baling mechanism. To save weight while maintaining strength, John Deere used a combination of different steel grades and thicknesses throughout the frame. This was good engineering, but it created multiple areas where dissimilar metals were welded together under high-stress loads. Over years of operation, these welds were subjected to constant cyclic loading, millions and millions of stress cycles as the plunger hammered and the flywheel spun. Microscopic cracks would develop in the heat-affected zones around certain welds, particularly where the plunger support met the main frame rails. These cracks were nearly impossible to detect without magnetic particle inspection or ultrasound, techniques that few farm shops had access to. The cracks would grow slowly, then suddenly accelerate. The typical failure pattern was catastrophic. A farmer would be running normally when they'd hear a sharp crack. The baler would suddenly become unbalanced, and inspection would reveal that the main frame had cracked completely through. Sometimes the crack would be 6 inches long, sometimes over a foot. The plunger mechanism would be shifted out of alignment, other components would be damaged from the sudden stress redistribution, and the baler would be completely inoperable. The repair was theoretically possible, but practically nightmarish. The frame crack would need to be carefully excavated, properly prepped, and welded with certified procedures. But here's the problem. If the frame cracked in one place, the stresses that caused that crack were present throughout the structure. Welding up one crack didn't prevent others from forming. Many shops wouldn't even attempt the repair, knowing that a frame crack was often a terminal diagnosis. Those that did attempt repairs often saw the same baler return months or years later, with new cracks in different locations. For farmers who had invested $30,000 to $40,000 in a 348, discovering a major frame crack was heartbreaking. The machine had been reliable for years, had produced thousands of perfect bales, and had seemingly plenty of life left. But a frame crack turned it into scrap metal almost overnight. Many 348s met their end this way, retired while their engines, knotters, and other systems were still in excellent condition, defeated by metal fatigue that was impossible to prevent and impractical to repair. So the next time you pass an old baler parked behind a barn, covered in rust and weeds, remember that it probably worked perfectly, right up until that final moment when something critical finally gave way.